or anything pre-loaded for today?
We'll be using the gapminder dataset. So you can just, if you have the gapminder package installed, that would be useful.
Maybe.
So if you can check just by going library. Gapminder.
Oh, something's come up.
Sorry, I was just closing the project that was open. Yeah, so if you have the gapminder dataset installed, it'll be really easy with just library gapminder, and then you'll be able to call the gapminder dataset really easily.
Oh yeah.
If you don't happen to have it, you just have to run install packages gapminder just the first time. Let me just get the comments or the chat set up. Alrighty. If everyone could just pop in chat what your experience is with using dplyr or R in general, just like what your experience level is, that'd be awesome for me to kind of cater to everyone's preferences. So if you're like kind of like a really beginner, like you installed R within the last couple of months or something, to where maybe you don't use R too much, but maybe you have in the past, so intermediate I'd say, and then I'd call more advanced anyone who's kind of writing their own scripts for everything, doing most of their stats in R and anything like that, I'd call advanced. Limited. Thank you. So today's all going to be about, so happy Valentine's Day. That's probably as far as I'll go with the Valentine's Day. Thanks everyone for coming, and thanks for succumbing to my corny email I wrote. Today's all about dplyr, which is probably, in my opinion, the most useful, love you too, Jake, the most useful package you can use in terms of processing data and summarizing data. Things hidden here. So we're going to be using the gapminder, but just before we get into it, I just want to explain. So we're going to be talking a lot today about something called pipes, and pipes, I think, are like the way to go with programming. Before we do that, actually, we'll just have to make sure that everyone's got dplyr installed, library dplyr. So again, if you don't have it installed, you might have to go install packages. dplyr. And again, these seminars, oops, I just pressed save, sorry. Save it quick. These seminars are best if you try and follow along if you can. And just let me know in chat, or just give me a shout if you're ever stuck at all. We'll try our best to help out. Jacob, Legana, and Natalia are all what I would call experts, so they can help you out with any coding troubles as we go along. And I'll also be keeping an eye on the chat, so let me know if anything gets stuck. But it's all kind of like following along for the most part. I just want to do a kind of a demonstration of why we do, why we're going to be using something called functional programming today. So functional programming refers to when you're sending code from basically in like a pipe kind of fashion. And what I mean by that is, let's say we had the MT cars data set, which is built in. It's got a bunch of vehicles and everything. And one common thing we use with this data set is we just want to fit like a linear model to it. So if we fit LM data equals MT cars, and then we just need a Y by X, so maybe miles per gallon by weight or something like that. This will just give us, you don't have to copy this, but this is just going to give us a linear model. So we're just predicting miles per gallon based on the car's weight using this really simple model. Don't worry too much about knowing the intricacies, but if we want to next do something else with this, maybe we want to get the residuals. So we go resid, I think it's resids, or resid. We put this around it. Now we get the residuals of that linear model. We can predict the residuals. And then finally, we might want to plot those residuals. So we go histogram of those residuals. And again, don't worry about copying this one just yet, just as a little working example. But if we do this, we'll get a nice little histogram of the residuals of our model fit. And so here we can assess, normality and everything else that we're usually looking at with this type of model. So obviously, it's not really important to us, but you can see kind of, if you've got this code, it's kind of confusing what's going on. We've got a lot of parentheses. So right away, what I would do is I'd go into code, rainbow parentheses would help. kind of dissect what's going on here, which one's coming first. So again, code rainbow parentheses can help with parentheses if you've got too many. It'll add a bit of color to your code. But otherwise, so that's kind of like the normal way of doing it. This is like regular way in R, or what I would sometimes call base R. But then the dplyr way is using pipes. So we've got this special operator called a pipe, and we can do all of this, and it's going to be a little bit longer in terms of lines, but it's going to be way more clear to anyone using it. So we'll maybe start off with the empty cars data set, and then we'll send it in a pipe to the linear model function. So now we can go miles per gallon by weight, data equals dot. And again, I'll explain exactly how this is working at first, but basically what this is going to do is going to take empty cars, send it to the next function, send it to this linear model, and it'll actually send it exactly where this dot is. So wherever you put the dot, that's usually where it will go, if not the first argument. So usually it'll go to the first argument of the function, linear model. But in this case, we want to go to data. So if we do this, oops, and I didn't load dplyr yet. So we just got to make sure you load library dplyr. There we go. Now we can run it. So you can see this is running the linear model. That's actually running the same as this first set of parentheses in here. The next one, we'll just send it to resid. And we actually don't need to put a dot. We can, but we actually don't need the dot. It'll work the same either way. And then finally, we're going to pipe it to histogram, hist. And now we've got the exact same histogram. It just changed the title, but we've done it in a really, really clean way that's easy to read. So that's kind of, this is the motivation for today. This is what the code we're kind of looking at. It's not about, doing it the quickest and easiest. We can do it this way using base R. When we've got a lot of operations, it gets really confusing. So the dplyr way is using these pipes, and it's basically, hopefully you all can kind of appreciate, we're just sending, each piece of it is kind of like a step in a recipe. It's like step 1, here's the data. Step 2, run our linear model. Step 3, get our residuals. And step 4, plot the histogram. And it's doing it step by step, whereas this is doing the same thing. It's just in a really oddly written way. So that's kind of the motivation with package dplyr. We're going to do everything really in a kind of a step-by-step way. So throughout this, I encourage you to kind of try and think of each step you want to apply to your data, and that will really help you use this package to the fullest extent in terms of everything we're going to do. But obviously, this package isn't just about using these pipes and making things clear. It's also actually about summarizing and mutating and creating new variables. So we're going to get into that as well. But for now, that's kind of our motivation why we're doing this. We're trying to look for this code that's really like clear and concise, and will be really easy to follow for other people as well. And we can even annotate different steps. We can be like step 1, data, do things like this, which is even clearer. Step 2, linear model. So this will make it really clear for anyone else following this. All right, so does everyone have the gapminder data set loaded? You just have to run library gapminder. And if it doesn't work, so hopefully if you run it and nothing happens, that's a good thing. That's excellent. Can anyone let me know if you don't have it installed? If you need it installed, you'll just have to, I wrote it at the top, I'll just copy it again. You just have to install it the first time. Awesome. But once you've installed it, you can actually comment this off. You don't need to install it a second time. So you won't need to run it again. You can put the comment sign and it should be good to go. All right. So I'm going to assume that we've all got it installed. And if you run gapminder and you pipe it to a head, we can even try piping to a head, as in, this is the same as writing head of gapminder. It just prints off the first 6 rows. 2 different ways of writing exactly the same thing right here. But let's just practice using the pipe way. Gapminder head, we can see the data frame pop up in our console, hopefully, and everything should be good. Cool. So the first thing we're going to try and do is we're going to try and summarize some of this data. So if you look at this data, we've got a bunch of different countries on different continents. And throughout the years, we've got life expectancy, population size, and GDP per capita. So we've got these kind of 3 kind of population responses through time for all the different countries recorded in this data set. So there's a ton of different countries. If we wanted to look at the number of different countries, you could write something like unique on gapminder $country. That would give us all the different countries in the world that we've got. And we've got 142 levels or countries in this case, in this data set. So we've got a ton of different data. You can do the same thing with year even. Unique year. We've got years 1952, and then kind of jumping 5-year periods all the way to 2007 in this data set. So if I wanted to make a really simple summary, like for something specific, let's say I want the mean of the GDP per capita for Africa only, for only countries in Africa. So if I wanted the mean GDP per, or for all African countries across all times, this is how we would do it using the normal way. So we'd have to do it like the mean of something, and then in the middle we'd have to add like the gapminder data set, but we would have to summarize it in terms of a specific subset. So we want gapminder in terms of row by column. So if you remember subsetting, the first index is the row, the second is the column. And don't worry too much about understanding what I'm doing here. I'm gonna just do it the kind of the bad way, and I'll show you why it's so much simpler with dplyr. So if we want gapminder, we do something like this. So this is getting the GDP per capita column, and this would give us the mean of all countries. Oops, get this right. Oh, and we just might need to add na.remove equals true. Oh, it's not working. Anyway, that's not actually what we're. What am I doing wrong? Anyway, from there we also need to filter by the African countries. So we go gapminder $continent equals Africa, and I don't know why my mean isn't working today. Is anyone else's code running for this? It should run. Mean people. I think it's just I might have a package loaded that's weird. No, it's running. Huh. That's really odd that mine isn't running.
I don't think mine's working, but I don't really know what I'm doing. Just trying to copy.
Yeah, maybe Jacob or Legana, if you can see what I'm doing wrong. It's odd because it's not working right now. But anyway, we're not going to do it this way anyway, so it doesn't matter. This should work. I'm not sure why it's not quite working just yet. Yeah, that should be fine. It might be because we have to actually pull out a certain data set. $sign. See if this works. There we go. Okay, so we just got to do it slightly differently. I must have changed something about, I didn't realize they changed that in R. But anyway, we can do it this way still. So what this is doing is we're doing the mean, that's like the big function overall. But if we work from the inside, usually we have to work from the inside for these things, is we're calling the gapminder data set. And this part is a subset. So we're specifically asking for all the rows where continent is equal to Africa. All right, so that's another kind of confusing step in there. Then we're calling a column after that from that data set that we just subset it called GDP per capita. And then finally, we're doing the mean of it. Super weird and confusing, right? Like if you looked at that, you're like, it's odd and it's hard to kind of fix what's going wrong and what step is going wrong. So we're going to work on this and we're going to get it a lot closer to what we actually want. So this is where we're introducing the dplyr package. Will help us a lot in this. So there's kind of 5 different functions we're going to be covering today. Select, and I might actually fit in a few more if I can get there. Filter, the group by. These are by far, I think, the most useful ones. Summarise, and you can. It's also worth noting that you can spell it either way, English or like UK English or Australian English or American English, doesn't matter. You can spell it with the Z, it will still work the same. So that's another nice thing about this package. It's pretty flexible that way as well. So we're going to go through each of these. Let's try the first one we're going to go through is just using select. So what select does, I'm just going to pull this out for a second. Select is going to be basically picking out certain data frames or certain columns from our data set and just taking those and making it smaller, basically. So we're just basically going to be selecting certain columns, taking them out and using them. Unfortunately, select is also one of those functions that always conflicts with other packages. So that means that other packages might load up select as well, and it basically makes R not be able to know which select you mean. So one thing we're going to do just to avoid that is we're going to try running this. Select is given by dplyr select. What this is doing is it's just saying whenever we use the select function, I want it to be from dplyr explicitly. So I'm just saying I want it to come from package dplyr. I want it to be our select function. So this should avoid any errors that we see about select not working, hopefully. So I actually write this at the start of a lot of my scripts, a lot of my R code, because I just want to avoid confusion. So this is to avoid conflicts with other select functions in R. Because there is also a base R select function, and that tends to always cause problems with it. All right, so the select function is super easy. It's kind of, the first thing we're trying to do is really, we kind of want GDP per capita. So, or let's just use it on kind of anything. So let's just start off with gapminder. We're gonna pipe it, and we're gonna go to pipe it to a select. So we're gonna select specific columns. So let's say we select the year, country, and GDP per cap. And that's just how they're spelled in this data set. If you have to remember how they're spelled, one trick you can use is going names of gapminder. And that will give you the names of the different columns. So just remember, R is case sensitive. So if anything goes wrong for spelling, it'll probably tell you, oh, we don't know where this column is. So you can always check it with just writing names of gapminder. This will tells us the column names. And this is going to be selecting specific columns out of the data set. So notice that when we do this names, and then we do this part, if I pipe this to another names, there we go, another names, we went from 6 columns down to 3 columns, and it's exactly these 3 that we have. So that's what select is doing. It's basically just picking out columns that we want and taking them out. And so from here, if I'm just going to delete this part I just added. From here, if we wanted to just make this a smaller data set, we might maybe call this like small gapminder. And we assign it the value of this, so making it smaller. So this is one way we would just make a smaller data set. Now we can run small gapminder and look at it again, just to see the same thing. We can see we've made it smaller. We just selected those 3 columns only. So it's not the most useful until you start doing, you have way too many columns in your data set. Sometimes you need to get rid of some. So it's really good for that. Select the ones that you do want, get rid of the ones you don't want, make it smaller. Another cool thing that you can do is you can actually, within select, you can rename columns. So you don't have to keep the same names. Let's say do the same thing, gapminder. And we go select. Let's maybe make, instead of having the same thing we had before, let's just rename them differently. So maybe I want to call year with a capital Y. So I'll go year equals, currently it's year with a lower y, but I'll just change it to year with a capital Y. I'll change country to from lowercase on the right to capital on the left. And then finally GDP per cap. I leave this to you, but you can change it to anything you want. GDP per cap, maybe I'll write it like that, is equal to GDP. Or you know, I might just call it GDP. PC, I don't know. GDP per cap. And if we try running this, we'll see now that the data set again has changed in terms of the column names. So select is a really easy way to just quickly change your column names as well. So select is also useful for that. Select is also, there's also a function just like select, but instead of picking out certain columns, we can actually just rename using it. And it's just called rename. It's really easy. So rename does the exact same thing as select, except for that it doesn't remove any columns. So if we tried this, for instance, rename year equals year, we're going to get all the columns, the 6 columns we had before. I think, yeah, the 6 columns we had before, but we just changed year in this case. So rename, it's like select, but just renames, no subsetting columns. All right. Now it's also really useful select because you can actually do some kind of intuitive things that you might guess about. So if I challenge you guys without even knowing it, guess how you would remove a column. Let's say if I gapminder and I go to select, let's say I want to remove the population column. So I want to remove this pop column. Any guess how we would do that? It's actually really simple. If we want to remove, think mathematics, it's just a minus pop. Yeah. So select minus pop will give us gapminder without that population data set or that population column. We just got rid of it by putting a negative there. So select is also really good because we can just pick out certain columns with negatives and delete them. So select is great for that. And again, if we were doing this a bunch of times, we'd probably want to save it. So this could be like small gapminder number 2. We could save it into this. And now we've got it saved as a smaller data set, small gapminder. All right, so that's kind of the functionality of select. That's like the basic one that we're gonna start with. So the next function that's really useful, and this is where I never even do regular subsetting anymore with it, is filter. Filter is super good. So if you think of select as subsetting columns, so it's picking out certain columns or removing certain columns. That's all columns. Filter is the opposite. Filter is for rows. It's subsetting by row. So filter subsets by row. And that's just right up here. Oops. Select subsets by column. And you can rename them. So filter, we're going to be, instead of subsetting certain rows, we're going to subset certain columns. Instead of subsetting certain columns, we're going to subset certain rows. Sorry, getting confusing now. And there will be a challenge question coming up. So if you're bored, we will get you doing something cool. All right, so we're going to start off like we always do. Start off with our data set. As is, we're going to use the pipe, and then we're going to pipe it to a filter. And let's say we want to filter by European countries. So we only want continent when it's in Europe. So right now we've got everything. We've got Asia, Africa, everything else in there. So let's say we just want to filter by the continent equal to Europe. So to do this, we just go filter continent equals Europe. But I've actually put in a mistake here on purpose. This is how you might think about writing it. But one thing the filter needs, just like the subsetting, is it needs it to be a kind of like a logical. So if I just if you imagine if I had like if I just had like gapminder $continent equals Europe, this is kind of what we're writing inside the filter. We don't need to write the gapminder $sign anymore because it's really smart. But if we try running this, I might have actually shouldn't have done that. Don't run this actually, everyone. I'm going to reload the gapminder data set because I just deleted something. It won't do what we want it to do. What we really want it to do is we want to put a doubles equal sign, because what that's doing is it's now saying, is the continent equal to Europe? In this case, it is. And I've messed up my R, so I might have to just remove my gapminder. Quick. Actually, what I'm going to do is I'm just going to reload the package again. So I accidentally overran all my columns with Europe. So now that it thinks that every single country is Europe. So I'm just going to re-upload the package again. There we go. So let's try it again now. There we go. So now it's just telling me true and false if it's equal to Europe. And the same thing in the filter. We're just going to want it filter double equal signs Europe. So to use filters subset by row, we're going to put a double equal sign. That's saying, is the continent equal to Europe? Give me true or falses. If it's true, it's going to give me European countries. If it's not, it'll get rid of them. All right, easy enough. What would we do if we wanted all countries that are not equal to Europe? Does anyone know the symbol for that? If we wanted to filter by every other country except for European countries, how could we do that? There's actually two ways. There's multiple ways, I believe, that you can do it. Filter by non. So oddly, it's actually, I've confused you probably because I've said that thing about mathematics and the negative, but oddly, when you're talking about logical statements like true and falses, it's got to be exclamation mark. It's the weird thing here. I don't think we can do continent equals negative Europe. Let's try it. Yeah, it doesn't work with negative Europe. So here's one way we can do it. We can use the mathematical sign for not equals to in R. That's just exclamation mark equals. That just means continent not equals to Europe. That's one way of doing it. We can also just take a statement that is true or false and invert it on itself. So basically make it true and false becomes false true by just highlighting this putting parentheses around this again and putting an exclamation mark at the start. So what this is saying is it says invert whatever is inside of this, true or false, invert it to the opposite. So now, oops, and I just got to put this back to equal sign. Otherwise it's a double negative. But so now we're saying continent equals to Europe and then invert that. And I believe this also works. Yeah, so they should give the same answers where we're getting everything not equal to Europe. Now, another cool thing that you can easily do in filter is we can add extra statements. So this first one was filter by European countries. So let's say we want to filter by European countries in the year 2007. Any idea how we could get the European countries in the year 2007 with our data set? We got gapminder, type it. We're probably going to use filter. And we want continent equal to Europe again, like we had before. Now, here's where we get, again, two other options we can do. So so we want it now, we want the European and then we want the year. Yeah, so I haven't changed my year to, I think it just auto-corrected, but it's year in lowercase, year equals 2007. That works. And you can either connect it with a comma. So a comma just means and, or we can just add in an and symbol as well. So that means the same thing basically. So we can either go like this, or we go and. Just note that if there's another symbol that you can use, it's called, so this is with the and symbol. There's also an or symbol, which is that bar, that just means or. Oops. Is or. So that would be, we want either they're in Europe or they're from the year 2007. So that's not really what we want in this case. We want both cases. We want that they're from European countries and they're in the year 2007. All right. So now we're going to try and write a function. So I'd like you also, I'm going to challenge you all and leave you to your own devices. I'd like you to make, kind of like I've been doing up here, but I want you to save it as an object. So I want you to make a new data frame subset. So I want you to save it as a new like object in R, where you subset by countries in Africa, and select and get out only the columns of year, country, and life expectancy. Oops. So I've purposefully not written out the column names as they appear in the data set. So you'll have to remember a few tricks on how to subset this properly. So this is the challenge. Get a subset of the data for only African countries. So we want a subset of only African countries, and we only want the columns year, country, and life expectancy being returned in that data subject. Okay, good to know. So can everyone try this out yourself? I'll just pause here for a sec, and maybe pop in chat when you're done, and then we'll try going through it together.
Kevin, maybe show how to get the cheat sheet, like in help.
So the cheat sheet for dplyr, if you go to help cheat sheets, there's a bunch of them. There's one for dplyr here. It will automatically download to your computer or try to download. So when you click it, it's going to download, I think, to me. Yeah, just pop to my downloads. Oh, there it is. So this is the cheat sheet for dplyr. There's a bunch of different things. But anyway, we're not quite there for some of them. We've just only done 2 of the functions. So using what you know, you should be able to hopefully do this challenge question. Also, we got one answer. How's everyone else doing for the challenge question? Everyone nailed already, or is it already? Is it trickier than we thought?
Kevin, I remember that you sent a link for regular expressions
Mm-hmm.
to, can you resend it perhaps, please?
Yeah. You mean the short course?
Yeah, something like to try.
Oh, I think I found it. Yeah, this is it. In the chat. All right.
Thank you.
I'm gonna take your. Does anyone need more time or good to go? So the steps we kind of need for this, if we're breaking it down in terms of steps. Oh, okay. I'll get it. Yeah. I like to kind of solve everything dplyr with like exactly the stepwise way of doing it. And yeah, oh yeah, as Legana said, I always use select for the same thing. Rearranging column names, or if you get like, you know, if you want like your ID column on the left-hand side, which tends to be typical, you can shift it using select by selecting the columns into a different order. It's really good for that as well. But let's just break this down, our challenge question, into kind of piecewise steps. So we want to get a subset of the data from the African countries and then get out the columns for year, country, and life expectancy. And actually just turns out it doesn't really matter which order we take, it'll still probably be the same outcome. So we probably want step one to either be, we can even do the opposite order. We can do select first, select columns of, oh no, we can't do it in that order actually, because we need continent. We need to use continent to get only the African countries. So we're gonna have to do in this order. We're gonna subset first. So we're gonna filter by Africa, or filter by African countries. Step two, we're going to select columns, year, country, life expectancy, which in this case, I think it's the trick here is I wrote life expectancy differently to how it's actually written out. So to check this, you might have to go names of gapminder, just to remember again that life expectancy is spelled like this, lifeExp. But once we spell it like that, it's pretty simple. We're going gapminder, pipe it to a filter, as Ronald's got, awesome, yeah. Filter continent equals Africa, type it to the next thing, which is just a select. So we're going to select by year, make sure it's spelled the same year as year, country, not countries, and life expectancy, spelled exactly like we've got it down here, using that names function. So don't forget, the names function is your best friend if you forget the names of the column names, which I always do. So there we go. That's kind of what we want out. And the last thing we need to do is just save it as an object. So we probably want to call this like gapminder Africa. And we can save it as, we can even put this on a new line. We don't have to have it on the same line. And now we've got a way of saving it. And we can quickly just look at this. If we just highlight it and run it, we can see that we've got only the African countries in there. That's perfect. That's exactly what we want. And if you remember from before, when we were talking about this really complicated operation up here, that's kind of the first step of it. We've actually done this inside part here. So what we've done here is selected only the African countries. That was the filter. And then we selected specifically the column of GDP per capita. We also took year and country as well, but we've basically done essentially what we've got in the middle here. The last thing we've got to do is get the mean GDP for all the countries. So from here, it's actually relatively easy. All we have to do is we can go mean of gapminder Africa, and then we just go $. Oh, I don't have life. Well, I can do the mean life expectancy. I didn't take in GDP per capita, but you get the idea. We just have to take in an extra data set where we get the mean life expectancy, for instance, something like that. So you can see how quickly we've gone from a really complicated thing to getting much, much simpler. And now we're going to talk about two of the most useful functions in dplyr, group by and summarize. And I put them together because we tend to use these ones often together. I'll show you exactly what it does. Basically, we go gapminder, group by, as the name suggests, is going to group by a specific variable. So we can group by, for instance, continent. If we run this, the data set will just pop up, but we've got this new thing here. And this is really, really, really important. So if you're already kind of used to this and you're advanced, just remember that this grouping is going to sometimes help you and sometimes hurt you. So when you're grouping by something, it means that all your future dplyr operations are going to be done group-wise. They're going to be applied based on a group. So for instance, here we're grouping by continent, and we've got this groups based on continent. If we want to get rid of the groups, all we have to do is pipe it to ungroup. Oops, ungroup. And that will get rid of it again, and then we go back to normal. So that's kind of how group-wise is going to be working. It's basically a way of telling dplyr, okay, I want everything to be done by groups or not done by groups. The summarize part is also cool. Gapminder also works with summarise. So summarise, as the name suggests, is we're basically going to be summarizing the rows based in a certain way. So whenever I use summarize, imagine that we're going to be collapsing everything row-wise, like we're summarizing it and we're going to make the data set smaller in terms of the number of rows. And probably the number of columns as well. So for instance, if I summarize by GDP per capita, I could go summarize mean GDP per cap equals. So inside of this, we're going to be writing what we want it to be called, and then we'll just do what we want it to do, basically. And this will with practice, this will make more sense. So for instance, this is giving me the mean GDP per capita across the whole data set, the whole entire data set. So what it's doing is on this part, we're saying we want it to do the mean of a certain column. We want it to do the mean of this GDP per cap column. And then we want to save it on the left as mean underscore GDP per cap. It's just an informal name. You can call it whatever you want. I could call it hello, Jacob, And now we'll see the column, it's now called hello, Jacob. You can call it whatever you like, but I like to call it something informative. So if I just go backwards, I'll call it mean GDP per cap. That's what the summarize is doing. But we notice right now, it's summarizing just in terms of the entire data set across every single time period, every single country. So that can be useful if we wanted to do that, but maybe we want to do it by continent, for instance. So how can we use the group by and the summarize together? Well, we literally just add them together, basically. We put them into the same recipe, and we can summarize really quickly by, for instance, continent. So summarize mean GDP per cap for each continent. So to do this, all we do is we go gapminder. The next one we want to do is we want to group by a certain variable, group by, and can you guess which variable it's going to be? It's going to be, we want to summarize by mean GDP for each continent. We're going to group by each continent, group by continent, because now we've got this grouped data frame. It's got this groups thing on it, and that's going to do something really important to the next part. So we actually can just copy and paste what we have above, actually. I'm just going to copy this and paste it down here. So now we've got gapminder, group by, and then finally summarize. And what this is going to do, it's going to produce this nice little table. We've got the mean GDP per capita for all the different continents based on all the different years. So this is in the past, obviously. So don't take this for nowadays, but this is kind of the mean GDP per capita for all the different countries, how they're all arranged. All right, so we quickly group by different continents and then summarize. And normally if you were doing this like in BaseR, you'd have to do this kind of manually. You have to randomly pick out a subset, do the mean of it, pick out the next subset, Americas, do the mean of it, pick out the Asia countries, do the mean of it, Europe, mean, Oceania, mean. It would take forever. But this way, it's just super easy. We can just add it to this. And if we want more variables, for instance, let's say we want continent and we want year. There we go. We've got mean GDP per capita for all countries, for for all the African continent, the whole African continent altogether, and in terms of year, and that's our mean GDP for each of them. So that's really the power of Summarise. We can do a bunch of different operations on the different data sets. So remember, when we're grouping them, though, we're kind of taking our big data set and we're dividing them up into groups, and we're applying each of the Summarise functions to each of these different groupings. All right, does that kind of make sense? Is anyone kind of confused by this, or does it kind of make sense? Other useful things we can do with this, in case you're running questions, is let's say we want the mean, we want the standard deviation, and we want the standard error of the mean. We can do all three of these things and all at once within this. So this is really common in statistics. So we have to report the mean and the standard error, or the mean and standard deviation. So let's try doing this for mean GDP per capita. So I'm just going to add a comma here, and I'll enter onto a new line for Summarise. Let's say we want the standard deviation of, right? It's awesome. I'm glad you're excited. Let's say we want the standard deviation of GDP per capita. So I'll just name it in advance, but you can name it whatever you like. How do you think we get standard deviation for all the GDP per capita? How would we do that? What would you write on the right-hand side for standard deviation? Does anyone know the R command? Hopefully someone's done standard deviation before now. Standard deviation is, if we use SD is the function for standard deviation, not stdev like in Excel, SD. So if we want to do the standard deviation for all the GDP per capita, all we have to write is just standard deviation of GDP per cap. All right, try running that. All of a sudden we've got standard deviation as well. Standard deviation of GDP per cap. Okay, so we quickly summarize, we got the mean and the standard deviation for every single, for all the continents and for all the years. And we could even change continent to country, and we could do it for every single country. But the problem is, I think then we wouldn't have, there would just be only one value for each year. So we'd have to we'd have to change this slightly. But you get the idea, it's really helpful. Actually, so now we're gonna actually have this kind of, you guys do something very similar with this. We've got a challenge question. Challenge. Calculate the average life expectancy per country. Ignore a year. Which country has the longest life expectancy, and which has the shortest? Sorry, so I didn't make this question, but we're going to try and follow it. So we're going to try and calculate the average life expectancy per country. And then once we got that, we need to find a way, and this second part is kind of a bonus. So don't worry too much if it's not super clear how we can do that, how we can get which country has the longest and which has the shortest life expectancy. We'll do that part as extra in case you're wondering, but let's try, and I'll get you guys to try and calculate the average life expectancy per country. Average meaning mean. So we've done it with GDP. How would we do it with life expectancy? So I'll just pause for another minute and I'll let you guys try this yourself. And let me know in the chat when you get it. All right, so just in the interest of time, because we're getting close to the end of the session, I might jump into it. Did anyone able to get through a bit of it? Hopefully. Awesome. Perfect. Oh, and this arrange is also a good one. Yes. So arrange is another one we haven't covered. It just basically sorts based on a certain column, and you can make your data set basically in order based on a certain column. So that's really helpful. Yeah. So I just divided it into a few steps. So we'll start with our gapminder. And this one is where we really need to use that group by. So if we want it based on per country, that's basically whenever we say per something, we usually have to do it by group by. So we use group by country. So before we use continent and year, this time we'll just use country because it doesn't say anything about doing it by year. And then we want to next summarize. And then we can summarize based on the mean of the life expectancy. And we actually don't even need to name it. I think it will work without the naming. Yeah, so we can get this. It'll just write it weirdly if we don't name it. So maybe I'll write mean underscore life expectancy just to be extra clear what it is. There we go. There's the mean life expectancy. And the last little bit, that bonus part, I think is the hardest part. We've got to find a way of filtering out the minimum and the maximum. So one way of doing it, and there's actually many ways of solving this. So one way would just be to just arrange the data set based on this mean life expectancy column. So if we arrange based on that column, at the top it'll show this is the lowest one. So Sierra Leone in this data set was the country with the lowest life expectancy. So this would be Sierra Leone for lowest. And if we wanted the opposite, we could just write a little negative here. Turns out negatives, we can use them here as well. And it'll give us in the opposite way. It'll give us the one with the highest life expectancy. In this case, it is Iceland for highest. So the arrange is one way of doing it. We can arrange based on negative and positive. Another way, if I just copy this, is to put it into that filter we used before. So if we use filter, and we want it to be basically where the mean, we want basically the minimum, or sorry, how should I put it? I would write the mean life expectancy. This is a little bit kind of tricky, but mean life expectancy, where it's equal to the max of mean life expectancy. So we either want it where the mean life expectancy is equal to the maximum value of it, or this we can use this or function where the mean life expectancy is equal to the minimum mean life expectancy. So this one's a lot trickier. We basically have to make like a logical statement that tells us when it's either the maximum or the minimum and return both of these in both these cases. So if we try running this, this gives us Iceland and Sierra Leone mainly because one of them matches the maximum and one of them matches the minimum. And that's what this is kind of doing with it. But this isn't as common. You wouldn't normally do something like this. But just for your interest, if you need to do it like that way. So does that kind of make sense to everyone? Slightly. You do it that way? Okay, fair enough. One thing that we probably can't do is we can't put in a comma here because then we get nothing because there's no mean life expectancy that is both the minimum and the maximum at the same time. So remember the comma is equal to and, so we really need that or operator in this case to get it out. So that or operator is super important. Awesome. Okay, I'm glad it's helpful. So there's just a few smaller functions that we can use as well. So if you've got gapminder, let's say we group by, let's say we've got gapminder and we group by continent. I'm just going to cover these ones fairly quickly because they're pretty simple. Basically, if we group by continent, if we want to tally up the number of countries that are from each continent, we could quickly go count. And this would give us the number of data points for each continent. So in this case, Africa had 624. That's not countries though, that's also time periods. So if we wanted as well, we wanted maybe year, group by continent and year. This is the number of countries for every year. So in Africa in 1952, there was 52 countries included. So group by with count is just a really easy way of counting the N or the number in each kind of category. So if you've got different categorical variables, you can quickly count them up really easily. N is kind of, so that's count. Count works outside of, or works on its own. And you can also do the same thing where we go gapminder and we just pipe it to count. it will just count out the exact number of rows in your data set. So in this case, there's 1,704 rows if we don't group it by anything. So count works on its own, whereas the n, this n function, oops, can't spell, n works inside of summarise. So n is a way of getting the number of a certain variable within summarise. So if I just copy something we did above, I'm just going to copy this. I talked about how we got mean and standard deviation, but we never got standard error of the mean. So if you remember standard error of the mean, SEM is equal to the standard deviation divided by the square root of our n, or sample size. So standard deviation divided by the square root of n, that's our equation for standard error of the mean. So if we wanted to do that as well with this, all we have to do is add another summarize column. We go at maybe SEM or SE, let's write SE underscore GDP per cap. Remember, this part is just the name that I'm giving it, so it doesn't really matter. We'll say the standard error of GDP per capita is equal to, and here we have to write our own function. So we're going to write SD of GDP per cap divided by, and here we need the square root of n. So we go to square root, that's the function for square root in R. And inside of this, we need the number of countries in each continent. So that's the tricky thing. How do we get that? Well, we can actually use n like this, and this will automatically tell Summarise to calculate out the number of countries in that grouping, in this group by, and give us basically this denominator term correct. So now when we run this will actually give us, you can calculate this yourself, this will give us the correct standard error of the mean if we write it like this. And you don't need spaces, remember, you just add spaces how you like. So again, standard error of the mean, we've calculated ourselves by using standard deviation of the GDP column divided by, and this is again grouped by still, so it's still being grouped by, divided by the square root of n. That's how we write the square root of n within a Summarise. So I really like to use this when I'm calculating standard error of the means really quickly. And from this, we can actually run it straight to a plot, and we can make a bar chart with little whiskers using the mean plus or minus standard error if we like. So it's really useful from here to go on further and save this kind of output, this Summarise output. All right, so that I just wanted to whiz through that super quick, how it's useful. The final function, and arguably, in my opinion, the most useful function of all that we're going to be covering is, what if we want to transform our variables in some way? What if we want to change, for instance, in this data set, we've got GDP per capita. What if we wanted to get it in terms of GDP per capita in billions? So for many, if you look at the data set again, gapminder, or let's put population in instead of being like this, let's write it in terms of units of millions. So I think we did this in a previous workshop. Let's say we want to change population, instead of just being the absolute number, and change it to a number in terms of population in millions. And all we have to do for that is just divide it by 1 million, and we'll get that. So to do that, there's a number of ways we can do it, but one way through functional programming to do that is just to use mutate. So this is like an awesome function. If you use this, if you end up using this a lot in your own coding, you'll find mutate is probably the one you'll use a lot, because basically, unlike Summarise, which is going to contract the number of rows you have because it's summarizing basically some kind of variable in there, mutate is actually going to keep the same exact number of rows. It's just adding an extra column. We're changing to a new column with this. So let's say we want population in millions. So population in millions. This is a new column we're defining. We're naming it in advance. We can call it whatever we like. But we're going to say it's equal to population size, which is currently a column in the data set. Population size divided by 1 million. So 10 to the power of 6 is 1 million, or a 1 followed by 6 zeros is 1 million. So this is now going to, if we do this, we get a new entire column name called population in millions, which is basically just our population size divided by 1 million. And that's how we get population in millions. And this is a really easier quantity to plot, for instance. So now we can see population in millions a lot easier. Instead of having these crazy big numbers that are kind of hard to read on your screen, we've got population in millions now. So this mutate, as you can probably guess, is super, super useful because we can quickly change things from this to other things. Another really useful thing about it is if we can add a comma here, and maybe we want to add a little bit more to this. Maybe we want to, I don't know, square root transform or something. this is weird, but let's say we just square root transform the population in millions. So we're going to make a new variable called square root of the population in millions is equal to, and instead of writing out the top part again, we can actually just write out this variable will be created first, and we can actually write out the name within this mutate function, and it's smart enough to know what's going on. So we'll write square root population in millions. And now we've got another column where it's just the square root of this value. So it's 8.43, square root it's 2.9. So we can, my point with this is that we can define some variable at the start, and then we can do even further transformations on it within mutate. So this is all within the exact same mutate function. So that's why I think mutate's like the coolest function ever. You can just do so much with it. Another really useful thing that I like to do is, let's say we want the, I don't know, change in population size across years. And this is probably the last thing I'll get to be able to do. So across year and country. So one thing that I often find with my Coral data set is I need to calculate growth manually. So I've got the size at a certain time period, and I got size of the next time period. And one thing that always drives me insane is I want to get the difference between these time periods, but our data set's kind of like this, it's in long format. So the way I figured out how to get basically change in something is you got to group by, and let's see, I haven't tried this yet. So I'm going to see if I can do this country and year. And then we can use mutate. And there's a function within mutate called lead and lag. Basically just gives you the next value down. So for instance, in Afghanistan in 1952, if I use lead, it would give me maybe the population size in the next time period. So in 1952, it would give me the population size in 1957 next. So it's going to give me the basically one value down from what I have. So I can go mutate population at time 2 is equal to lead population. Let's see if this works. Maybe I didn't do it right. Oh, I know why. I can't group by year, sorry. There we go. So now you've got population size, and the population size at the next time step, which is actually this same value. And the reason why I'm doing this in mutate is because now I can quickly subtract them. So I can get change in population is equal to pop at time 2 minus pop currently. And this gives me basically if a population went up or down through time. So basically now I've got change. Okay, they increased in the year for going from 1977 to 1982. Afghanistan decreased heavily, and that might be due to some kind of war or something. Who knows exactly, or a famine possibly. So now we can actually see the changes really easily in our data, and we can even plot this from here. So mutate's really good. I didn't get to spend too much time on it, but you can create all sorts of variables with this. We can even create another variable from this. Maybe I'm just kind of going with it. Sorry if anyone has to leave quick. I'm just going to wrap up in just a sec. Thanks, Katrina. Let's just make one variable called positive or negative. Positive or negative. And it's just going to be equal to if else the change in population size is greater than 0 or positive, we'll say that it is it increased. So we'll give it a value of 1 or something. And if it, or I don't know, let's write positive. Otherwise, if it went down, we'll write negative. So one thing you can do in mutate as well is you can add if-else statements to it. So you can actually, I've just written an if-else statement based on this change in population variable that I've defined up here. If it's going to be a positive number, it's going to return positive. And if it's a negative number, so if this isn't true, then it's going to return negative. So now when we run this, we can actually see positives and negatives. Yes, and case one's awesome, yeah. So this case one's for another time, but anyway, positive or negative. And lastly, maybe I want to just count up, summarize this, just to do something finally with this. So let's say I want to summarize, maybe I want to summarize based on the number of positives and negatives. So maybe I'll just actually, one thing I can do with that is I can go group by again, group by country and positive or negative, and then I can count them. Let's see if this works. So I've got some errors that I have to fix, but basically you can see, so there's a bunch of countries And if I want to see the whole thing, I could write view, and I'll open up a new window. So I'm just doing this really quickly. We can see most of the countries are positive growth. There are some negatives. For instance, Bosnia and Herzegovina, I'm guessing during the Bosnian War, were decreasing. They were negative 2 cases. There's also a bunch of NAs, so we just have to filter those out as well. It's due to the way we did it. But we can quickly see kind of which countries went down. So for instance, another one was Germany was negative in 2 time periods. So I'm guessing, I guess maybe close enough to after the war that it was negative at that time. Anyway, you can see really quickly just the power of filters and everything else when you put it into practice. So sorry, everyone, I kind of went over time. I think that's all I've got time for today. Does anyone have any questions about mutate, group by, and everything? Mutate's one you just kind of got to practice yourself. This is a bit crazy what I'm doing up here, but what's more common is when you're just kind of manipulating variables, like just changing them to different units and things. You can change them, for instance, from centimeters to meters and stuff like that really easily just by using mutate. So I find myself using mutate quite a bit just to make new variables as well. But sorry, it got a little bit rushed at the end. But yeah, thanks for listening. And let me know if you have any questions, or if you want this code, I can send it to you.
Thank you, Kevin. It was amazing as usual. I have a question. It says when I put the group by and then summarize, it says that the summarize is overwriting my group by.
Oh. Is it when
like
you
it's almost like I don't need. It's not an error. It's just like a warning.
I think yeah. So I think what it's just trying to tell you. I think it's doing that on purpose just to warn you. As long as it's not an error, I think it's. I've seen that before. Is it happen because you're saving a variable? I'm guessing, right? You're probably going. Maybe you're saying this gapminder.
Yeah.
Summarise.
Yeah, you can. It's a new thing they've implemented. You can do that, like the dot groups, and you do equals false or something, and then it won't work.
Oh, okay.
Yeah. It's no big deal.
Yeah, it's just warning you just to let you know that it's group by, because in the past people just were trying to run this without noticing that it was group by things, and then it gave really weird outputs to them. So it's just trying to warn you, just to let you be aware it's grouping by something. So just and I think, does this work? I don't know. I'm not sure what the groups is, but yeah, I honestly don't even touch it. I just let it be. It'll always give you that, but yeah. There's some way of getting rid of it. I just haven't figured it out yet. But yeah, so it's, as long as it's not an error, it should be okay. Yeah, good question. Another thing that I didn't mention too much, but it's really good at the end, if you're still using your data set, to just ungroup it. If you've made groups like I have up here, the last thing I might want to do is just write ungroup, because if you forget that you've got it grouped, and then you go to use it for something else, it will still be grouping by whenever you use commands. And so this even works, I think sometimes in ggplot2, it might even take the group by as well. So you got to be careful when you go to do some things, always ungroup at the end. And just to verify, you can look, and at the top, it should just say a tibble and not a tibble and then groups or anything like that. Like this is gonna have groups, right? So you can see here, I got the groups and I need to get rid of them with ungroup. So that's another really important thing. That will lead to errors that are really hard to fix because you don't know where it's coming from, but it turns out you just have to ungroup it. So that's why, yeah, that's one thing to be really wary about.
Cool, thank you.
I really just want to filter. I just want to fix this now. Filter. There we go. Getting rid of the NAs. Yeah, NAs are
Obsessive compulsive.
There's NAs in there because I'd use this lead, and in some cases at the end of the data set, there's no more data to take from, so it gives NA at the end. It's just a normal part of using lead and lag. These ones they always produce NAs, but you can just get rid of them. But yeah, anyway. Thanks everyone for listening. What's on next week? Next week, also super useful. Probably the best session for if you are ever need to reshape your data. If you get output from an equipment or a machine or something and it's in a really weird format, this session is the one for you because it'll help you change it around variables. So for instance, sometimes you get like data that's like in crazy long or wide format, they call it. and you want to get it so it's more like long format like we have here, or at least like partially long. So next week, Natalia will be talking about that and giving you all the hints and tips on how to transform your data. Yeah.